Now we're going to look at some very basic statistics using numbers. The first ones are, things you probably have seen already in maybe elementary school or algebra 1. First one is mean. Mean means average. So what you do is you add up all the data, so sum of the data points, and then you divide by how many there are. So the number of points. Median. Median means middle. So what you want to do is you first have to put the data in order from the smallest to the largest, and then you find the middle of the data points. If there are even number of points so that there is no true middle, then you would take the average of the two middle numbers. The next one is mode. Mode means most. So the number that happens the most is called mode. Now, this is kind of confusing to people. Mode is not frequency. So we look at which one happens the most, and then we say that number is mode, not how many times. How many times is not mode. That number itself is mode. Okay, range is the difference between the largest number and the smallest number. Smallest. All right, outlier is the number that is very different from the majority of the data. And then we'll kind of see how we can determine what the outlier is. Let's look at this example. The table below lists the length to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. Of the mean, median, range of the values listed, which will change the most if the 24-inch measurement is removed from the data? Okay, so once we understand what each basic statistic actually does to the data or how it's used, we can figure this out really quickly. But this is the first example, so I kind of want you to practice finding these statistics. So the first thing is, let's find the mean. Now, there are 21 numbers, so you'll have to add up all 21 numbers and divide by 21, but there is a slightly faster way. So instead of using your calculator and put in a plus 9 plus 9 plus 9, you can see that there are 3 9s. If there are 3 9s, you can just say a plus 3 times 9, because there are 3 9s, and then there are 2 10s, and 2 11, and so on. It's a little bit faster. And so that's kind of the same thing as if you have a frequency table. If you have a frequency table, then kind of like the last section, you would basically put this in category, right? So you would say 8 happened once, 9 happened 3 times, and so on. If they actually gave you the data like that, then you would just multiply by that, multiply the number with how many there are, and then add it together. So that's a much faster way of figuring out the mean. All right, so once you solve this, you get about 12.476. Median. Median is just the middle number. So there are 21 numbers, so the 11th number must be the middle. So you just count 11 from the 11th place from either the smallest number or the highest number. So we can just count. There are 7 across the top, so 7, 8, 9, 10, 11. Okay, so median is 12. Range is the difference between the biggest number and the smallest number, so that's going to be 16. And they already told us the outlier is 24, and you can see that too. So most of my numbers are between 8 and 16, and all of a sudden there is a 24. So 24 is very different from the rest of the data, so we would call that an outlier. Now the question is, which one's going to be changed the most if this 24 is not in the data? Well, so the question is really, which one of these three is going to be affected if there is not a really big number? All right, let's think about mean. If I take out this 24, what's going to happen to the mean? Well, first of all, my sum will be slightly smaller, but I will divide by 20. So I'm still dividing by a very big number, but I guess the summary is it's not going to be affected by too much. It's going to be slightly lower because you took out a really big number. So the average obviously is going to be slightly lower than 12.476. Median. Median is dependent on the position. So this is dependent on position, right? Because it's just the middle, wherever the middle is. So let me finish writing this. Be dependent on position. So since it's just the middle, you took out one number, it's just going to move one spot, if any. In this case, it's only going to move half of a spot. So it really will not change much. And you can see that the majority or the mode is 12. So it's still going to be 12. Now let's look at range. Range is the largest number minus the smallest number. Now if you took out the largest number and you make it into a number that is not as large as the previous one, obviously this will change a lot. So this is definitely going to be very much affected if that 24-inch measurement is not there. So those were really basic statistics and just kind of how we can analyze data, even if we just have those basic things to look at. Now, there are other ways to look at data, and this is another way. This is called a 5-number summary. And what they are is it kind of summarizes the data in 5 numbers. So minimum, Q1, median, Q2, and maximum. All right, minimum, obviously the lowest number. Q1 is a little bit harder because you've never seen it before. Q1 means the median of the lower half of the data. What's the lower half? Lower half just means everything that's lower than the median, because median, remember, means the middle number. So the lower half is just everything that's smaller than the median. Median is the middle number. Q2 is the median of the upper half. So same idea as Q1, but for upper half. Maximum is the biggest number. There is a thing called interquartile range. Interquartile, so Q1, Q2, they are the quartiles. So interquartile is basically talking about, I'm sorry, this is not Q2, this is Q3. Sorry about that, that's Q3. So interquartile range is going to be Q3 minus Q1. So it's a way of measuring how spread out the data is. But in general, this whole thing measures how spread out the data is. All right, let's go ahead and look at this one. Find the 5-number summaries for the male and female life expectancies in South American nations and compare the spreads. Okay, and then we're going to create a box plot. All right, so let's go ahead and look at male first. So we are going to create the 5-number summary, so that means we need minimum, Q1, median, Q3, and then max. Okay, so let's go ahead and look at the male data first. So let's kind of put in the numbers that's very obvious. So we have 12 numbers in each of the categories, and they already organized it for us from smallest to largest, so this should be pretty fast. So for male, the smallest number is 59.0 and the highest number is 72.6. The median has to be right in the middle, so it has to be the average of these two, and that's pretty easy, 68.75. Q1, So the lower half of the data is going to be here, and the middle of the lower half has to be here. And so what you want to do is, again, find the average of those two numbers. And that is 64.1. Q3. Q3 is finding the middle of the upper half. So the upper half is what I circled, and the median is going to be right there. So that is going to be 71.65. Okay, now let's go ahead and have you try. Go ahead and find the 5 number summaries for the female data. Now go ahead and check your answer. Hopefully you got the same thing. Now what we're going to do is graph the box plots. So first we're going to do the male. And what you want to do is just put the 5 number summary as tick marks on this chart. So the smallest number I have is 59, so a little bit less than 60. 64.1 is next. I know it's not super accurate, but we're doing our best. Median is 68.75, and then Q3 is 71.65, and then maximum is 72.6. So we have 5 lines here. Between Q1 and Q3, you're going to use Q1 and Q3 to create your box. And then from the middle, you're going to connect it to the top and the bottom. Okay, so this is my box plot for male. Okay, now let's do it for the female. The smallest number is 66.2. And then the second number, Q1, is 70.25. And then 74.5, 77.7, and then 79.4. Again, you create a box with Q1 and Q3, and then connect the lines like that. So what we're looking at is how spread out the data is. So they're pretty comparable in that most of the data here are spread out the same. So remember, most of your data is going to be contained between Q1 and Q3 because minimum and maximum are usually going to be the ends, and there's not a lot of data that's going to be at the two ends. Most of the data are going to be stuck in the middle. So we can see that most of the data spread is about the same because they have kind of the same length. This one is a little bit closer to the maximum. That means most of the data is going to be closer to the maximum than in the actual middle. While for the female, most of the data, even though the spread of the data between male and female are the same, for the female, the spread of the data is towards the middle, while the spread of the data for the male is towards the top where the maximum is. So if you do decide to take AP Stats next year, you're going to go into this in much more detail than what I'm doing here. I'm kind of just giving you a very quick summary. Next year, if you do decide to take AP Stats, which I highly encourage you to do that, it's a really good class. You'll be analyzing a lot more data and kind of know what you're looking at. All right, the last thing we're going to do is normal distribution. This is a very common thing to know. So normal distribution means that your data is spread out in such a way in what we call a bell curve. So you can see that this is kind of a very symmetrical curve. So this is called the normally distributed curve. And if your data ends up like this, then you can say that this middle is this symbol. The symbol is called mu. It's a Greek letter, and always means the mean. So in the middle of the curve is the mean. And the next symbol you see is this one here. That is called sigma. Sigma means standard deviation. Standard deviation is a way of calculating how much the data deviates from the mean. So from the mean is at 50% of the data, to the right-hand side, where I put that line, that is 1 standard deviation away from the mean on the right. And then this is 1 standard deviation away from the left of the mean. And this predicts 68% of the data. So notice this only works if it's a normally distributed graph, meaning that the mean is pretty much the same as the median. It is in the exact middle. So if that happens, then on the right-hand side and the left-hand side, 1 standard deviation away from the mean, that is 68% of the data. And then if we go 2 standard deviation away, then that much data is 95% of the data. Okay, 95% of the data is contained within 2 standard deviations. The last one is 3 standard deviations away. 3 standard deviations away from each side of the mean is going to be 99.7% of the data. Then where is the 0.3? 0.3% are the sum of the rest, and those sometimes can be outliers, or sometimes it's just really far from where we can predict. So the most important thing you need to remember is 68, 95, and 99.7. Okay. Now, how do we actually use that? Let's go ahead and look at this question. Your company packages sugar at 1,000 grams bags. When you weigh all the bags, you get the following standard distribution with standard deviation of 20 grams. First question, is this a bell curve? Bell curve means, is it normally distributed? It looks like it is, so we're going to say that is a very nice bell curve. If it is, mark the mean and the standard deviations. All right, so this must be the mean. And this is going to be 1 standard deviation. This is going to be 2 standard deviations. And then this is going to be 3 standard deviations. So this is how it's lined up. All right, next question. If you tested 3,000 bags of sugar, how many bags fell within 1 standard deviation of the mean? Okay, so we talked about this before. 1 standard deviation of the mean is going to be here. Different color. Here. And 1 standard deviation away from each side of the mean is predicted by 68% of the data. So 68% of the data fell within 1 standard deviation of the mean. When they say within 1 standard deviation, they mean left and right together. So the question, however, is how many bags? Well, that's going to be 68% of the 3,000 bags of sugar. So you multiply that together and you get 2040 bags. Next, if you pick a bag at random, what's the probability that the weight is between 1050 and 1070? 1050 and 1070, that's going to be here, which is 1 standard deviation away from the mean only on the right. So the question is, what is the probability? Probability, remember, just means percentage. So what's the percentage that is where I boxed? Well, within 1 standard deviation on the left and the right, that's 68% of the data. Since this is only the right-hand side of the 68%, this must be 34%. All right, last one. If 3,000 bags were tested, how many bags would fall between 1050 grams and 1070 grams? So it's the same question, but it's asking you how many bags instead of what is the probability. Then you just take 34% and you multiply by 3,000. And you get 1020 bags. All right, so time for you to practice these last two. I'm gonna get you started with the first one just so that you get used to drawing these kind of bell curves. All right, let's read the question. A radar unit is used to measure speeds of a car on the motorway. The speeds are normally distributed. Normally distributed is kind of the key. It tells you that it's going to be a bell curve. With a mean of 90 kilometers per hour and a standard deviation of 10 kilometers per hour. What is the probability, that a car picked at random is traveling at more than 100 kilometers per hour? All right, since it tells me that it is normally distributed, I'm going to draw a bell curve. And it tells me that the mean is 90. So I'm going to put 90 here. And each standard deviation is 10. So the first standard deviation is going to be 10 away from the mean. So this is 100. And then this is 80 because it's 10 more and 10 less. Let me make this a little bit darker so you can tell this is the center. Okay, the next standard deviation is going to be another 10 away. So that's going to be 110 and 70. The third standard deviation is going to be another 10 away, so 120 and 60. So the question is, what's the probability that there is a car that's faster than 100? Car that's faster than 100 is going to be here. So the question is, what is the percent that's here? All right, I'm going to give you some hint. This much is 50% of the data, right? Because the mean is in the middle for a normally distributed graph. We know that this part is 68%. So I think this gives you a very good hint of what the shaded area is. So go ahead and solve this one and come back and check your answer. All right, so this is pretty simple. It's just going to be this much, 50% minus this much. Now, this part is just the half of 68%, which is 34. So 50 minus 34 is 16%. All right, let's go ahead and have you try the last one. So again, what you want to do is read the question. If it says normally distributed, then you start drawing your bell curve starting with a mean and then fill out the whole curve with how much the standard deviation is. All right, so the question is between 50 to 80. Between 50 to 80, that is 2 standard deviations away. And so 2 standard deviations away, left and right, is 95% of the data. But we only want the right-hand side of the mean. So that's half of 95%, which is 47.5%. Now let me ask you a more tricky question. What if the question said, what is the probability between 80 to 95 hours? Okay, 80 to 95 hours is here. Then what are you going to do? Go ahead and try it and then come back and check the answer. All right, the answer is 2.35%. So what you want to do is take this much of the data, which is the half of 99.7%, and then subtract this part out, which we already found is 47.5%. And so the answer is 2.35%.